Hi everyone, my name is Phillip and this is CSE424 Capstone II, and I'm going to give you a high-level overview of software-defined networking today. And this is a very complicated subject, a lot of little details, so I'm not going to go into all of those, just going to give you like the basic overview. I'm very interested in cybersecurity, that's why this has actually drawn an interest in me, because it is a topic that is mentioned a lot with cybersecurity professionals and networking professionals, yet not a lot of students really know about it, it seems like, or really understand what it is. And from what I've researched, it is the future of networking. So, software defined networking is a very important topic today in the computing world as networks become more complex and harder to maintain. The agenda is I'm going to go over the references that I use to research software defined networking, give you guys current networking challenges that we face with the traditional networks that we have, go over an overview of what software defined networking is, explain why we need software-defined networking, and then give you guys a quick conclusion of this video. And then any questions you guys have, you can leave them in the comment section under this video. These are the references that I use for this video. The first one right here is the Open Networking Foundation website. They have a lot of useful information on there. This one is the Cisco website, kind of a blog on software-defined networking. This one is an article from the Open Networking Foundation. And this one is a kind of like a slideshow on software-defined networking. This one is a peer-reviewed article about software-defined networking and how it interacts with cloud computing. A lot of good information in that one. So the challenges that we face today with the traditional networks are complexity, inconsistent policies, and inability to scale. So the abundance of networking protocols and features that we need for these specific use cases that keep coming up are increasing our network complexity. This is because older technologies are often recycled because they're used for quick fixes and then businesses throw them away and find something else for another quick fix. Features for networking also tend to be vendor specific, and this causes a lot of inconsistencies between how networks are configured. Security and quality of service policies in networks are also need to be manually configured, which creates hundreds of different scripts and different things between businesses. So there's not one way to do a specific thing in traditional networking. And of course, this inability to scale with all of the different needs for bandwidth and speed is harder to do with our traditional networks. So what exactly is software-defined networking? Well, it is a framework that allows network administrators to automatically and dynamically manage and control a large number of network devices using high-level languages and APIs. And it basically consists of three layers: the application layer, the control layer, and the infrastructure layer. And I'm going to give you guys a brief overview of all three of these layers. The application layer is basically the most intelligent layer of the software-defined networking, hence the dog playing chess. It's a very smart dog. But this is where all of the user interfaces are that actually enable the management of the network via the control layer. So these are the interfaces that users can use to actually input data that the control layer actually uses. So it's basically an interface to interact with your network and manage the network. With this application layer, applications can be more network aware of what's going on with the network, as it uses this northbound interface to interact with the control layer and see what is going on within the network. The user can fully specify the needs that they have for this network by using these network applications. And the applications are also used to monitor the network state. So any business user can be logged into these network applications and monitor the state of their network or get alerts if something were to happen. The control layer is an essential part of the software-defined networking. It is basically the key component that differentiates software-defined networking from traditional networking technologies. It is this layer right here that is logically centralized, which provides a control point to provide broader view of the entire network as a whole and enhances the tracking of low-level details that is used by this layer. So it is decoupled from the data plane in a sense, which is different than our traditional networks right now. It summarizes the network state for applications, which I mentioned before in the application layer. It uses the control layer to get the overview of how the network is. It translates the requirements of the application layer into low-level rules that the data layer or infrastructure layer uses. So basically, this is the control of software-defined networking. And an example of open source software-defined networking controllers are something like Floodlight and FlowVisor. The infrastructure layer is basically the basis of any network. It is this layer down here that includes all of the equipment that enables traffic forwarding, which could be switches or hubs. And in traditional networks, the infrastructure layer comprises forwarding decision-making algorithms. However, these algorithms vary from vendor to vendor and are very static, which severely restricts network flexibility and the ability to adjust these networks. So software-defined networking gives a more intelligent approach to this, as forwarding algorithms are decoupled from networking equipment and they are actually implemented in regular programming languages, which makes them easier to change and more dynamic. So the infrastructure layer also uses the OpenFlow protocol, as it is the most popular way of connecting the infrastructure and control layers in software-defined networking. The infrastructure layer also consists of traffic processing functions, which basically take care of all the traffic that passes through the network and forwards it to the correct locations. If the benefits weren't clear before, I'll clear them up right now. There's obviously the business agility that gets increased as businesses can start using software-defined networking to create more automation within their business, as well as create a more centric and policy-based nature. And then there's also the popular use cases of software-defined networking. Because big data and everything as a service is becoming more prevalent, software-defined networking helps automate and deploy these new architectures. And then we're just going to keep expanding and expanding. Software-defined networking can be applied across the entire computing infrastructure, not just the network. And this extends programmatic control to all of the IT resources that applications require. It is going to become a vital role in distributing policies across the entire infrastructure. So in conclusion, traditional networks are clearly more restrictive and more complex, and as we keep desiring to do more and more with our internet and with our networks, software-defined networking will continue to rise and grow as it is becoming more and more essential. So I don't know if you knew about software-defined networking before you watched this video, but I feel like personally more awareness is needed for software-defined networking as more and more of us research this and contribute to it, it'll just become even more useful. And any questions you guys have, just leave them in the comment section below this video, and thank you for watching.